Hey, previously we discussed a possible attack on the blockchain where someone could create a block with an arbitrarily low difficulty value. After all, the difficulty adjusts according to the mining rate of the system. So, what's preventing someone from doing some funny business and setting the difficulty to something like 1 or 2? That way, they could generate an extremely long chain using blocks with really low difficulty values. Currently, we don't have any guards against that. Ouch. But let's implement the code to protect the blockchain now. This starts in the blockchain.test.js file. In the existing isValid chain section, let's add a new test for a new invalid chain case. And in this case, the chain is going to contain a block with what is called a jumped difficulty. So in this case, we're going to have a new case where the chain has the genesis block correct and multiple blocks. But instead of the last hash changing or an invalid field, we're going to have a new situation where the chain contains a block with a jumped difficulty. And then we have our callback as usual. And in this case, well, it should return false as well. So we'll say that it returns false for the test in this case. In this test, we'll construct a bad block that has a jumped difficulty. Essentially, we're going to copy the code from the mine_block function here, but we'll modify it to use a really low difficulty value. So the trick is still generating a valid hash based off of a low difficulty. It's not like we can just set the difficulty to a low value and expect the valid block to be created. It still needs to pass the isValidChain function in terms of generating a correct hash. But we can start from the very start with a low difficulty that is clearly wrong. So first, what we're going to need to do is we're going to need to find the last block in the chain. We'll find that by looking at the blockchain.chain and getting blockchain.chain.length -1 for the index value for that last block. Then let's grab the last hash, which is that last block dot hash value. Likewise, we'll create a timestamp, which is date.now, a nonce, so how about a nonce of 0, and then our data can be a blank array. So I'll pull this up right next to the mine difficulty code. So you'll find that so far, this looks very similar. We have the last hash, we're getting the timestamp, we're getting the nonce, as well as a data field. But then now comes a funny business. Instead of the previous block difficulty, let's now set the difficulty to an arbitrary jumped value. So let's set the difficulty to the last block dot difficulty -3. All right, and now we can generate a hash for the block. So at the top of this block.chain.test.js file, well, let's require our crypto hash method. So let's require crypto hash from the local crypto hash file. Great. And now in our new invalid test case, we're going to generate a hash that is the result of calling crypto hash and then putting in all these fields, including the jumped difficulty. So that's the timestamp, the last hash, the difficulty, the nonce, and the data. All right, cool. And finally, we can create a bad block now by making a new block instance. So let's call this bad block. This will be a new block. And the input to this is going to be the timestamp, the last hash, the nonce, the difficulty, and the data. So all of the fields for the block that we just created. And let's all place this on its own line so that way it's more easily readable. Cool. Finally, we'll push this bad block to the blockchain. So let's push it to the blockchain so that way it contains the bad block. And now let's expect that if we call blockchain.isValidChain in the static method, and we pass in the blockchain.chain, which now contains that bad block, well, this should be false. All right, great. So make sure you have all those changes. I'll also place this in a better format. All right, cool. So all the constants are right next to each other. And once you have this saved, make sure you have the test running in the background. And as you do so, you'll find that there is one new failing test. And in this case, we received true for this new chain, even though it contains that bad block with the jumped difficulty. So we need to add some protection against this. All right, so the way that we're going to fix this is that we're going to go into the isValidChain method, and we're going to make sure that the difficulty never adjusts by more than 1. We definitely need a guard for this. The solution is to enforce a rule in the isValidChain method that the difficulty never adjusts by more than 1 value. So head back to the main blockchain.js file, and then we're going to go to the isValidChain method. And now we're going to add a new condition where if the last difficulty minus the current difficulty is greater than 1, well, we're going to return false. So let's grab a constant of the last difficulty right at the top. So let's get const last difficulty is equal to chain of I minus 1 dot difficulty. So that is the last difficulty for the block prior. All right, now we can add our if condition. If the last difficulty minus the destructured difficulty from the current block, if we find that result is greater than 1, well, we're gonna return false from the overall isValidChain method. And as we save this, the test runs again, and now we have a fully green test suite once more. Cool, so now this should prevent difficulty jumps going too low. Another thing that we want to prevent is difficulty jumps going too high. So what we can do is we can take the absolute value of this difference, so that way you can't adjust the difficulty in the positive direction either. So at first, this might seem like a weird thing to worry about. Why would you care about someone raising the difficulty too high? And why would someone want to do that anyway? Well, if someone were to raise the difficulty of this system, they could slow down the entire blockchain network for everyone involved. With such a high difficulty, it would be hard for the blockchain to have enough time to generate a hash that meets the difficulty criteria. All right, with that, we've completed the core logic of the overall blockchain. Awesome job. Give yourself a pat on the back, pop some bottles of champagne, however you like to celebrate, do it. We have the block and the blockchain structures, as well as a core proof of work system, which controls a rate at which new blocks should be added. Next, let's bring this blockchain to work with multiple consumers, so that way multiple blockchains can interact with each other. We're going to create a blockchain network, and this is where the true power of the blockchain and cryptocurrency comes in. When there are multiple individuals and nodes working together in an overall blockchain network. So let's add this crucial feature next.